Good evening, everybody. We are getting ready to start on day 3 of Advent of Code in C++ on the stream here. Thanks to everybody who's watching. Um, we have about a little under 8 minutes to go before the puzzle unlocks. So I just wanted to do a little follow up from last night's stream. Um, One of the things that I talked about last night was wanting to make the parsing of strings in those password policies and descriptions work a little better because we just sort of read them into a um, a fixed size buffer and copied some strings around. So I want to show a couple of different solutions that I came up with for that are a little bit better. So this first one I did in part 1 just to show it. So one thing I thought about is if we're reading a substring from this password string, then we know that the substring can't possibly be longer than the original string itself. And this +1 is for a null terminator, although with these other characters in here, we wouldn't even really need that. So what we can do here is we can make a dynamically sized buffer just using makeUnique to make a character array of that length, and we can read it into that. And then this automatically gets converted to a C++ std string here at the end. So that dynamically sized buffer is one way to make reading the strings safe. But this kind of got me thinking that maybe we can do a little better than this. In particular, maybe we can avoid copying between the original string and this intermediate buffer and the final string. So I made this little helper class in my IO library called Substring Scan Helper. And really what this helper class is doing is it's kind of just adding some convenience around using the n specifier in a scanf format stream. So an n specifier means that instead of reading information from the stream to an output variable, what you're actually reading to the output variable is just the number of bytes that have been consumed from the stream so far. And the z here is just a width specifier. That means that we're going to use, instead of int, we're going to use size t. Then this s here is just read a string, like read the substring that is the actual password, like we did before, like we were doing before. This star here, as part of the specifier, means that we want scanf to scan over that string up to white space, but we don't actually want it to store it anywhere. And the reason why we don't want it to store anywhere is because all we want scanf to do is move past that string. But then we're going to finally read the position again after it goes past that string. So basically, these two zn specifiers, we're going to read the byte position of the start of the string and the byte position of the end of the string, and in the middle we're going to skip over the string itself. And what they'll let us do, we know the start position and the end position, we can just take a substring out of that. So this substring scan helper class kind of helps with that. We put the original string in here in the constructor. We put this first param and second param here. These are the minimum and maximum positions for the actual substring. And then once scanf is finished, we can call this result method and just get the substring out. And since this is using a string view all the way through instead of a standard string or something else, we're not actually copying any of the underlying string data. We're just kind of slicing our views of it. So I can go back to the day 2 solution, and you can see kind of how this works. We have the same beginning to the scanf format that we originally did, where we're reading 2 unsigned integers with a dash between them, then we're reading 1 character, the validated character, and then here there's this little macro substring format which just expands to that string that we were just breaking down, and we read that into the first 3 parameters are just the same parts of the password format string that we were looking at before. And then these last 2 parameters just come from the helper class. Now the interesting thing to note here is that those n specifiers for how many bytes you are into the string. When those are read out, they don't actually increment the count of matches. And that star s specifier to skip over the substring, that also, because it doesn't because of the star, it isn't actually reading out to any variable. That doesn't increment the counter either. So the actual expected number of matches here is 3, just for the first 3 parameters. But none of the rest of it in that substring format increments it at all. And then finally here, we use that result method to actually produce the substring from the helper, and it gets automatically converted and copied out to an STE string in the password struct here. So that is how we kind of neatened up yesterday's stuff, and all that stuff is in the GitHub repo now. That's at github.com/craig-chasseur/AOC2020. And in my profile on Twitch, you can go to the URL from there as well. So we now have about 2 minutes until tonight's puzzle unlocks. So I'm just going to make a little bit of scaffolding here for the program that we'll use to solve it. So we'll call it day 03, part 01. And we will put a little main.cc in there. This is all old hat by now. Just the absolute minimal C++ program. And we'll put a build file in there for Basil to know how to build it. Okay. And we will go ahead and run it now. Compile and run it. Target parsing pattern failed. Oh, yeah, because I have to actually put day main on the end of that, of course. And it ran, and it did nothing, as it's supposed to at this point. Okay, let's go over to my browser window here. We have less than a minute to go before tonight's puzzle unlocks, and then we can get started. So one thing you hopefully notice is that the audio quality is a little better. We hopefully won't have as much clipping and distortion tonight because I'm using this headset mic that my partner graciously loaned to me instead of the integrated mic in my webcam, which was having problems with clipping and distortion. So hopefully that all sounds a lot better tonight. Shout out to her. She is Tansy4 on Twitch if you want to watch her gaming streams. All right. Puzzle is unlocking. The sudden burst of traffic is happening. There we go. Toboggan trajectory. So we got our login problems resolved. We're headed towards the airport. Travel by toboggan might be easy. It's certainly not safe. There's minimal steering and the area is covered in trees. You'll need to see which angles will take you near the fewest trees. Due to the local geology, trees in this area grow on only exact integer coordinates in a grid. You can make a map, your puzzle, of the open squares and trees you can see. Okay. These aren't the only trees, though. Due to something involving arboreal genetics and biostability, the same pattern repeats to the right many times. Okay. You start at an open square and you need to reach the bottom. Toboggan can only follow a few specific slopes. Start by counting all the trees you would encounter for the slope right 3, down 1. So from your starting position at the top left, check the position that is right 3 and down 1. Then check the position. Okay, so go on, so on and so on until you go past the bottom of the map. The locations you check in the above example are marked with O, where there was an open square, and X, where there was a tree. Okay. All right. Let's get our input. Make sure that looks okay. Cool, cool, cool. Okay, so first things first is we'll just read in the lines. Well, first things really first is that we will check that we get exactly one argument to our program besides the program name itself, which will be the file name that we want to read in. We'll read lines from a file, be argv1, and then we'll make sure that that's okay. And so, you know what? I am very sorry. I realized that I was not even showing you typing on this. I had left my stream on the other screen. So I apologize. And so you can see what I've written here is that we're checking the number of inputs. We're reading the lines. We're checking that that's okay. So we will say that each line we're going to count starting at the top goes 0, 1, 2, 3, 4, and then from left to right 0, 1, 2, 3, 4. So maybe I'm going to make a little helper class for us here. Call it tree map. Which sounds like a very generic data structure, like it's a B tree or something, but it'll actually be a map of trees that we are sledding through. Use a vector of strings for the internal map. Put in a little constructor to take the lines that we read. Okay. So then we can have like a little struct to represent coordinates. So first thing I'm going to do here is something where we can just get the next coordinates from moving from a certain position. So we can say just int. So we can say like however many we want to go down and right, and then that will get us back, like normalized coordinates inside of our map. So so the vertical part of that is going to be just the original dot. Yeah, well, this is pretty simple, really. We'll actually just copy the original, and then for the vertical part of it, we will add down, and for the horizontal part of it, we will add right. And then if we see, well, so if we see that we've gone beyond the limits of our map. So we say if the new vertical position is greater than or equal to the size of the map, because we're counting from 0, then greater than or equal to the number of rows in our map, then we will return null opt, which means nothing. And then we will go to the right, and if we and the pattern just keeps repeating right, right, right. So if we find that we are further to the right than what we think is the edge, then we will renormalize that so that it's in range. So then we'll just say dest.horizontal, and we will do that, make that modulo. Alex, really, I think you can do modulo assignment like that. So we're basically like doing modulus division. So we'll be doing the remainder when we divide by the width of the map that we have. And so we will, all the rows should be the same size, but we'll do it from our current position. And so then that will be our normalized position, and we can return that. And then, go ahead and format that. The other thing that we want to be able to do is for a given set of coordinates, check if something is a tree. So we can say we just look at map. And again, I'm not going to do any bounds checking right here. I mean, if we were being really careful, we would, but we're not. And trees are represented by hash marks, as I recall. So we just check if that is equal to the hash mark at those particular coordinates. And now, to actually solve this, we can do count trees on path. And we'll use the down and right to specify the steps of the path. We'll say step down and step right, so that's a little more clear. So we will start at the origin. So we'll start at the origin. Well, actually, let's say abcell optional coords. That'll be our current position. And we'll just initialize that as the origin, because we're starting at 0, 0 in the upper left corner. And then, so we'll say while position.hasValue, so while we haven't gone off the bottom edge of the map, we're going to keep an active count, int trees equals 0. So we're going to increment trees if there's a tree at our current position. And then we are going to get our next position. And then we just repeat the process, checking each position that we go to if it's a tree or not, until we go off the bottom edge of the map, and we return our full count of trees. So now we just print our output here as, well, so we'll actually make a tree map. First. Our step down is 1, our step right is 3. Okay, so I think this is our solution. We need to, of course, add our dependencies. So we shamelessly copy what we had here. We definitely used check and IO, and we used type/optional. You know, since I'm compiling in C++17, all this stuff is actually in standard C++ now, but I'm kind of just used to using the abcell equivalents. So let's actually, I'm going to copy the test input that they gave in the intro just to see if that works. So it says 7, which is the correct answer for the test input, so let's use it for the real thing. Okay, we hit 187 trees on that map. That is a lot. Ouch. Let's see if it's right. Go 187. 187 on an undercover cop. Okay, so that is correct. So part 2. So time to check the rest of the slopes. You need to minimize the probability of a sudden or boreal stop after all. Determine the number of trees you encounter if, for each of the following slopes, you start at the top left corner and traverse the map all the way to the bottom. Okay, so this is really simple with the tree map class that we already have, because we already made count trees on path take a step down and a step right parameter. So all we need to do is multiply that all together. So reading the puzzle here, we need to do 1, 1. We need to do down 1, right 3. We need to do... I realize that I'm not doing this in a part 2 directory. I will clean that up afterwards before I commit this in Git. We're going right 5 down 1. We'll go right 7 down 1. And we will go right 1 down 2. As a super long line, we will go ahead and format that so that that's nice. So just double checking 3, 1, 5, 1, 7, 1, 1, 2. Okay. Meant to say product, not products. That should be count, but whatever. Okay, so let's run the new version of our program and get that product. And let's see if that is correct. Okay. It is not correct. So what might we have gotten wrong here? So that's 3, 5, 7. Okay. Let's do this. Let's run the same program with the test input. And it says the answer is 336, which is correct. Is it possible that we are in an integer overflow situation? Is the sum just really that big? Or the product, I'm sorry, really that big? It's entirely possible. Let's go ahead and see what happens if we change this to use int64 everywhere. And that on day 3. Yeah, you know, that is exactly what's happening. It's a big-ass number. Yep, there we go. So yeah, moral of this story for today is that if you are multiplying some reasonably big numbers together and you got a bunch of them, you might wind up exceeding the precision of the data type that you use in C or C++. So yeah, I mean that's always something to think about. And in fact, you know, it's very tempting to just use int everywhere and, you know, think, oh, you know, that's fine. That is, you know, my standard integer type. And in some languages, like for example, in Python 3, there is only one integer type and it has infinite precision. Like you will never overflow it. It will always expand to accommodate whatever values you put into it. But you need to be a little bit more precise in C++ because overflows can happen if something gets too big for a 32-bit integer, if it's bigger than about 4.5 billion. And that's for unsigned, actually. It's more like 2 billion for signed. Then it will go ahead and wrap around. And actually, overflow for signed integers is in fact undefined behavior in C and C++. It's only actually defined for unsigned integers. So yeah, that's kind of something to watch out for. I think maybe I will just, as we go forward in the days, whenever we're working with numbers, I will maybe tend to use 64-bit types more, just to be a little bit safe. In my I/O library, I kind of already templated, you know, the part of this that reads integers so that we can use a different integer type. But yeah, we've got our solutions for today. I'm going to look at maybe my personal stats here, and see where we got. Okay, so you can see every day, you know, the top few thousand, you know, it's not that bad, but there's some people that just go really, really fast. They're not talking through everything while they do it. So, you know, I think we did pretty good tonight. So I'm going to go ahead and clean up some of this stuff and actually split apart the part 1 and part 2 solutions into separate programs, and then get that all up in the GitHub repository. Again, you can find that at github.com/Craig-Chasseur/AOC2020. I'll put that on the screen right now. That's the GitHub repository. This stream recording will also go up on YouTube later tonight. But I think that's about it for us tonight. So I am going to go ahead and stop the stream. And I will see you all again tomorrow night where we tackle day 4. Bye-bye, everybody.